Hello, welcome back to Pre-Calc. This is a video over Unit 10. We're going to be talking about Section 2, which is called Law of Cosines, okay? And what we want to do is apply the law of cosines to solve mathematical and real-world problems. So before we do that, I want to develop the law of cosines, okay? So what I want to look at here is we have this triangle ABC. And again, what we're trying to do is we're trying to figure out we want to figure out all the measurements of a triangle, right? So in this triangle, what I've done is we have angles A, B, and C, and we have side lengths C, A, and B. Now what we did is we created this line here called H, which is the height of our triangle. And what we did was we made this length here X. And then, since the whole length is b, the remaining value over here is b minus x. So if I take the whole length, subtract off x, that leaves me with this, okay? Now, what I want to do is write about what we know, okay? So let's do this. Let's come in here and it kind of gives us some of the things here on our paper. But what I want to do is I want to write out the Pythagorean Theorem. So this is a right angle. So let's put in here that this is a right angle. All right. And so we have these side lengths here. And I can write the relationship that x squared plus h squared is equal to c squared, based off of that, okay? Now, if I write in the other Pythagorean theorem, then I would get h squared plus the quantity b minus x squared is equal to a squared, okay? Now, the one thing that I want to do here is I'm trying to get some sort of equation out of this, okay? The other thing that I can do, so we want to have three different equations here. And given this triangle here, I'm going to find cosine of angle A. So I'm going to come in here and write a third equation, which is cosine of angle A would be my adjacent side, which is x, divided by the hypotenuse, which is c, okay? And then what I'm going to do is I'm going to solve this equation for x. I'm going to multiply both sides by c, multiply both sides by c, c's divide out, so I get that x is equal to c times cosine of A. All right, so I've got this equation here, and I've solved for x. So I've got something in terms of angle A, and side length C, and that's going to give me the value for x, and we're going to use that later, okay? The next thing that I want to do is I'm going to solve this second equation for h, or h squared, okay? So what I'd want to do is I'd want to subtract the quantity b minus x squared from both sides. So I end up getting that h squared is equal to a squared minus the quantity b minus x squared. Now I'm going to use this, all right? I'm going to plug this value in and substitute it into h squared of my other equation, okay? And so let's do some math here. So I've got, I'm going to write this out as x squared plus, instead of writing h squared, I'm going to write a squared minus the quantity b minus x squared, and that's going to equal c squared, okay? Now, the next thing that I want to do is let's multiply this out, okay? So I'm going to do, I'm going to FOIL this out. All right, and so just so we can kind of see our steps I'm going to subtract, I'm going to do b minus x times b minus x, and that's going to equal c squared. All right, so we're just going to multiply everything out. Now, because I'm subtracting this entire quantity, what I want to do is I'm going to subtract the quantity. So whatever I multiply out, I'm going to leave inside parentheses so I can distribute my negative later. All right, so let's multiply it out. B times b is b squared. B times, that's not right. B times negative x, so minus bx. And then the inside is minus bx. And then the last one is going to be plus x squared. Okay. Let's combine our like terms in the middle. So x squared plus a squared minus the quantity b squared minus 2bx, and then plus x squared is equal to c squared. All right. So I want to distribute this negative here. All right. And so what we end up getting is we get x squared plus a squared minus b squared plus 2bx minus x squared is all equal to c squared. Okay, so let's clean this up. Notice that your x squareds cancel out. Okay, and so then you're left with a squared minus b squared plus 2 times b x is equal to c squared. Okay, so we're down to here. Now the only thing that we have, when you're thinking about this, what we've done is we've just used Pythagorean Theorem on both of these, combined them together to get everything in terms of in A, B, and C. The problem is that you have this x here, okay? Now, what I have is this. Okay, I'm going to replace x with what we found earlier with c times cosine of a. Okay, so this part here I'm going to replace. So a squared minus b squared plus 2b times c times cosine of angle A is equal now to c squared. Okay, now we're not done yet. Okay, we're almost done. What I want to do is I want to solve this equation for a squared. Okay, so I'm going to add b squared, and I'm going to subtract 2bc times cosine of angle A, and I'm going to do that to both sides and move it over. So I'm going to add b squared minus 2bc times cosine of A. All right. So now here's what we got left. We're left with a squared is equal to c squared plus b squared minus 2bc times cosine of A. This is the first part of the law of cosines. So what we have now, this is the first part of law of sines, okay, or law of cosines. And what we can do is write the same thing for every other angle measure. Now the way I remember this is that, and we'll just look at the first part. I have a squared here. I start my equation with a. Then it's equal to the other two sides squared. So it's similar to writing it like the quadratic formula. Minus 2 times the sides b and c times cosine of that opposite angle from side length a. Okay, so we can extend this and do this for other sides. So let's do the same thing for b. So I could write this out as b squared is equal to c squared plus a squared minus 2ac times cosine of angle b. I could do the same thing for c squared. Okay, so if I write c squared is equal to a squared plus b squared minus 2ab times cosine of angle c. So all of these are different ways to write law of cosines, okay? And that's what we do. And that's what we have, all right? And so this relationship works in any triangle, okay? And we can use the law of cosines to help us solve problems, all right? So let's take a look at the next page so we can look at how you can use this. All right, so the first example that we have is that we can do, we want to use side, side, side to help find some angle measures. Now, in this question, it just wants us to find what angle Z is. Now, let's look here, and I'm going to label this triangle. We already have X, Y, and Z, but I'm going to label this side as side length Z, side length Y, and side length X, okay? Now, because we're solving for angle Z, remember, we're going to want to have cosine of Z. So I would write this out like this. I would say that Z squared is equal to X squared plus Y squared minus 2XY times cosine of angle Z, okay? And so let's do this. Let's plug in the values that we know. We know that Z is equal to 8, so I'm going to plug in 8 squared is equal to 6 squared, which is X, plus Y, which is 3 squared, minus 2 times 3 times 6 times cosine of angle Z, which we don't know. So in this example, when you have side, 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 and you're trying to find an angle, this is when you would use law of cosines, because you know all the side lengths. You can plug all those values in. The only thing that we don't have is Z. Now, let's kind of clean this up a little bit and see what we got. So 8 squared, let's write as 64, is equal to 36 plus 9 minus 2 times 3 is 6 times 6 again, so 36 times cosine of Z. All right, so now let's isolate cosine of Z. All right, that's what we want to isolate. So let's move everything over. We can combine 36 and 9, so let's do that first. 36 and 9 is going to give me 45 minus 36 times cosine of Z. All right, I'm going to subtract 45 from both sides. So we've got 64 minus 45, which gives me 19. So I've got 19 is equal to negative 36 times cosine of Z. So now let's do this. Let's divide by negative 36, okay, on both sides. And we're going to get that negative 19 over 36 is equal to cosine of Z. Now I want to make sure we're in degree mode because we're finding this in degrees. But if I wanted to solve for Z, okay, what I could do is I could write this as Z is equal to cosine inverse of negative 19 over 36. All right, and let's go ahead and solve for that. So once we put that into the calculator, we end up getting that Z, and let's round this to 3 decimal places. Let's just do that. We don't really have to. A lot of times they want us to round to the nearest degree, but we get 121.855 degrees, okay? And that's our angle measure, okay? So angle Z is equal to that. All right, so that's how we would use law of cosines, okay? The next one, we want to use law of cosines to find all the other angle measures, okay? So all the other angle measures, all the side lengths, okay? So real quick, let's write out up here what we currently already know. We want to find angle A, we want to find angle B, we want to find angle C. We already know what angle A is. It's going to be 76.5 degrees, okay? We want to find side length A, side length B, and side length C. Okay, so side length A, we don't know. Side length B is 32, and side length C is 44. Now, one thing that I'm taking from this is that because they rounded this to 1 decimal place, that's how we'll find all the other angle measures. We'll round that to 1 decimal place. Okay, so now, the question is where do we start? And using law of cosines requires us to use all 3 sides. Okay, so what we want to do is we want to find the third side that we don't know in order to start this. Okay, notice how we have angle A. This allows us to use that first portion of law of sines. So the first step, we want to solve for side length A. Okay, and here's what we got. We have A squared is equal to B squared plus C squared minus 2BC times cosine of angle A. Now, the reason why I do this is because I already have side lengths B, side lengths C, and angle A. That's why I'm solving for this first. Okay? Then once we find A, then we can use that to find angles B and C. Okay? Like we did in the top one. All right. So let's do that. So side length B, so let's plug all these in. A squared is equal to side length B, which is 32. So 32 squared plus C squared, which is 44 squared, minus 2 times 32 times 44 times the cosine of A, and A is 76.5 degrees. Okay, now, to solve this for A, all I would want to do is take the square root of both sides. Okay, so what we can figure out is that A is equal to the square root of 32 squared plus 44 squared minus 2 times 32 times 44 times cosine of 76.5 degrees. All right, this is what we want to plug into our calculator. Okay, it's going to be long, but there's no, at this point, because we're using a calculator, there's no point in simplifying this and going down that road. Okay, so go ahead and just plug that in the calculator, and we'll see what we get. All right, so we're going to get a value of A is 47.985. Okay, let's go ahead and round this and get that A is equal to just 48. All right, let's just round that to the nearest whole number because it's really close. Okay, that's one of the reasons why I just think that's reasonable. All right, so I'm going to plug it in here and find that A is equal to 48. All right, so now we want to find angles B and C. All right, so we use that part of law of cosines to get there. Now, it doesn't matter which one we solve for. We have the option to choose C or B. And frankly, it doesn't matter, but what because if we find one, then we'll use properties of a triangle and subtract it from 360 to find the other one. So it's a zero-sum game. Doesn't matter which one we choose. I'm just going to go with B, okay? Just because I don't know. No idea. No reason. Okay, but let's write out step 2. We're going to solve for angle B. All right, so let's do this. Let's use the one where we use angle B. So that would be B squared is equal to A squared plus C squared minus 2AC times cosine of angle B. All right, so B squared, B was 32. All right, so let's just plug our values in. So 32 squared is equal to 48 squared, plus c squared, which is 44 squared, minus 2 times 48 times 44 times cosine of b. Now this one, let's go ahead and simplify this just because we are solving for angle B, and it'll make it a little bit easier for us to plug this stuff into the calculator. So let's write out 32 squared is 1,024, okay? 48 squared is 2,304, plus 44 squared, which is 1,936. So now I've got negative 2 times 48 times 44, so negative 2 times 48 times 44 is going to give me minus 4,224 times cosine of angle B. Okay, so now let's move all these numbers over. Let's first combine our like terms here. So I'm going to do 2304 plus 1936. And so I get 1,024 is equal to 4,240 minus 4,224 times cosine of angle B. All right, so here's what I've got. I'm going to subtract, so we're going to isolate cosine of B. So I'm going to subtract 4,240 from both sides, and I get 1024 minus 4240, which gives us negative 3,216, and that's going to equal negative 4,224 times cosine of angle B. At this point, yeah, let's divide both sides by negative 4,224 by negative 4,224. And so we get, and we could simplify that fraction, but let's just write it as positive 3,216 over 4,224. There's no real reason to simplify it if we're just plugging it into the calculator. So let's write this, now let's solve for B. So angle B would be cosine equal to cosine inverse of 3,216 over 4,224. Okay, and let's plug that in the calculator. So that's going to give us an angle measure of angle B, which is, and we'll round to 1 decimal place, so 40.4 degrees. And it should make sense. You know, you should get, obviously, an angle measure that's going to be below, obviously below 180, but it should make sense to you, okay? It should make sense because angle A is 76.5, and that's across from the longest side, okay, which is 48. B is the smallest side, so that angle measure should be smaller than A. Now, when we plug it all in, angle C is the middle, side length C is the middle length, so angle C should be the middle angle. So now that we know, let's find angle C, all right? And you can do law of cosines to do that, but that's just a lot of extra work to do something that is very simple. So step 3 is solve for angle C. Now, here's what I know. Angle A plus angle B plus angle C, all those add up to 180. So let's plug those in. I got 76.5 plus 40.4 plus angle C is equal to 180. So 76.5 plus 40.4, those are going to give me 116.9 plus angle C is equal to 180. All right, so now subtract both sides by 116.9. All right, so 180 minus 116.9 is going to give me that angle C is equal to 63.1 degrees, which makes sense because it's lower than angle A. All right, so for angle B, we get 40.4 degrees. Angle C, we get 63.1 degrees. Okay, so the last thing we need to talk about here is exploring bearings. So bearings are noted as the acute angles off the fixed north or south line with an additional notation of whether the direction is east or west in the north-south line. So what you do is you start here, and so all your bearings start with north or south, okay? So bearings, let's just write this down, that bearings start with north and south and end in east/west. Okay, so what we look at, if we have this angle here, north 25 degrees east. So we start up at the origin. North is our initial value, and then we move 25 degrees to the east. Okay. Same thing with the second one. South 40 degrees east. So start on the south axis and go 40 degrees from the south axis east. All right, the other one, south 20 degrees west. So south 20 degrees west goes this direction, and then north 25 degrees west goes in that direction. So you have an example of what these look like in each quadrant and how we would write them, okay? So, but here's what we've got. So let's use the bearings and use that concept to draw a picture and to, answer a question, okay? So here's what we got. Two boats head out of port at 5 a.m. One travels north 60 degrees east at 12 p.m., and the other travels south 68 degrees east at 8 miles per hour, not 12 miles per hour, not 12 p.m. To the nearest mile, how far apart are they at 8:30 a.m.? So this is kind of one of those weird questions. One of the first things we need to understand is this, that we have that we're trying to find the distance apart from each of these boats, right? So we want to use the equation distance is equal to rate times time. So we're going to use that, okay? The next thing we want to do is to draw a picture, okay? And so here's north, south, west, east, okay? And so what we have is travels north 60 degrees east at 12 miles per hour, okay? So what I'm going to do is I'm going to come in here and I'm going to change up my colors. One travels north 60 degrees at 12 miles per hour. So I'm going to draw this picture here where we travel in this direction, okay? Knowing that this angle measure here is 60 degrees, okay? The next one I have is south 60 degrees east at 8 miles per hour, all right? So I'm going to do that. Let's draw an angle going in this direction, okay? And this is a 68-degree angle, okay? So the next thing I want to do is figure out the lengths of these lines. We have to use the fact that they're traveling 12 miles an hour and 8 miles an hour. Now, the time that they travel between 5 a.m. and 8:30 a.m. is 3.5 hours. So the time is equal to 3.5 hours. All right, so to find the one in red, all right, my distance would be 12 times 3.5 hours, and that's going to give us the miles. Okay, so that's going to give me a distance here of 42 miles. Okay, the other one that I want to do is the one that's traveling 8 miles an hour. So we're going to do distance. Our rate is 8 times 3.5, and that's going to give us a value distance of 28 miles. Okay, so that's what we have, and we can. I'm going to go in here and kind of erase this and change this up a little bit, just so we've got something reasonable here. So I'm going to go ahead and stop this point here and call this a distance of 28 miles. And then this distance here is going to be 42 miles. Okay. What we're trying to do is figure out the distance in between these ships at that time. Okay. Now, because this whole thing is 180 degrees, minus 60, minus 68. That's going to give us a value of 52 degrees. So this angle in here is 52 degrees. Okay, because I have two sides and an angle, okay, let's use law of sines. All right, and let's call this, x squared is equal to, so we've got 28 squared plus 42 squared, so we're going to use law of cosines, minus 2 times 28 times 42 times cosine of angle x, which was 52 degrees, okay? So we can kind of call it whatever we want, but as long as we're following, here's the third side of my triangle, here are my other two sides, 28 and 42. It doesn't matter what order they go in, but as long as we have those values there, okay? So again, in order for us to solve for x, all we have to do is take the square root of both sides to solve for x and plug that into our calculator, okay? This is a calculator question. So let's go ahead and do that, plug that in, see what we get. So on this, we get a value of 33.1. We want to round this to the nearest mile, so 33 miles once you plug that in the calculator. So that's the idea behind this, and kind of a cool way where we can use law of cosines, law of sines to solve application problems. So pretty good stuff. All right, thanks a lot. See you later. Bye.